It says find all the zeros of the quadratic function. So first we're going to factor, but when it says find the zeros, what it means is when is x 0? Where is the x-intercept? Well, in order to find the x-intercept, I make y 0. In order to find the y-intercept, you make x 0. So it's one of those things that we learned kind of back in chapter 1. I want to say that might have even been an item 1 actually when we were doing that. So I'm going to make y 0. I'm just going to go ahead and do it ahead of time. And I'm going to factor these pieces. So the only way to get x squared is x times x. These are both positive, so I know I'm adding. And all I have to do is break apart 30 to figure out, okay, what factor of 30 adds up to 13? So 1 and 30, nope, that won't do it. 2 and 15, those would subtract to 30, but we're not subtracting. Let's see, 3 and 10, oop, that works. So 3 and 10. And once I find the factor that adds up, I can stop. Most likely there would not be another one. So I can go ahead and take a break on that as far as factoring and go ahead and focus on the problem now. So now that I have it factored, I can set both of them equal to 0, just like I did on that last one. And I just need to solve. So minus 3, these guys cancel, and I have negative 3. And minus 10, x. These guys cancel, and I get negative 10. So there are my two factors. And again, I was anticipating 2 because of that square. So that definitely lets me know there that kind of identifies how many I should be looking for. So we have negative 3 and negative 10. Check. So let's go ahead and get started here. So as you saw in the example, we're going to do some long division with some polynomials. And there are multiple methods for this one, but we're going to start with this long division method, and we'll see where they move us to throughout this assignment here. So when we're doing long division with polynomials, what we want to do is we always want to figure out, what do I need to multiply this first piece by, this x, to make it match what's in the first position here. So I'm going to have to multiply by 2 because I want it to be 2, and I'm going to have to multiply by x so that it when I multiply x and 2x, it becomes 2x squared. And then I also have to multiply that by 4. So 4 times 2x is 8x. And I'm going to draw a line and subtract just like I would in regular division. The 13 is going to come down, and then 12x minus 8x, that gives me 4x. 2x squared minus 2x squared, those cancel out. That's kind of what I wanted to happen there. All right, so now this piece is my new first term because it brought down. So now to multiply x and to get it to be 4x, all I'd have to do is multiply by positive 4. Oop, close that. So 4 times x is 4x, and 4 times 4 is 16. And I'm going to subtract. So 13 minus 16, and remember, I know it says plus here, it's a positive 16, but I'm subtracting these like I would in regular division. So 13 minus 16 is negative 3. 4x minus 4x cancels out again, which is what we wanted to happen. So now we've gotten down to negative 3. There's nothing I can multiply x by to get it to just be negative 3. This is called a remainder. Okay, so this is what's left over. So my quotient is going to be 2x plus 4, the piece we have on the top here, and my remainder is negative 3. Alrighty. All right, another division method is called synthetic division. So here we have this, and this is what it looks like on Alex, and you go through and you have to type in each one of these little squares just to fill in the blanks. But what it is you still have a polynomial divided by a binomial, so it's telling you what to divide by. And in the last example, we would have taken this and gone like this so that we can actually see them kind of separated, 6x minus 7, like that. And then I would have said, okay, well, how do I turn x into x cubed? Well, I need x squared there, because x squared times x gets me x cubed because that's 3 of them. And then I also have to do plus 7x squared because I have to multiply by this one as well because there's a 7 here. And then I subtract, right? So x cubed minus x cubed, those cancel. And then I end up having this down here, and I'm going to change the color really quick. Just it'll make a little more sense in a second while I'm changing the color. So I would end up having 1, because when we're doing division, remember we're subtracting this whole row. So that's a normal part of division, is that you subtract the row to see what's left over, and then you divide what's left over again by what's here. So you keep going, just like in normal long division. This should be a 2. I don't know why I did a 3 there. I did that on my last one too. Okay. And then I have x squared here. And this stuff is just going to come down like this. Okay. And so we would keep on going here. You know, how do I get x to be x squared? Well, I need one more x, so I go plus x, and I do that same process all over again. Well, we can do that same thing with what's called synthetic division. It just makes it not necessarily simpler looking, but we kind of get rid of some of the extra junk in here, some of the variables and things like that, just for a moment to make it a little easier to deal with the numbers. So if you notice, I have -7 here, and that came from this. We actually use the opposite because it's x plus 7 equals 0, so the root is not +7, it would be -7, because I would subtract 7 from both sides like this, and I'd have x equals -7. Okay, so make sure you're paying attention to that idea. You don't want to just say the root is 7. The root is actually the opposite of what you see, because you have to solve that. So that's where that -7 came from, is what we're dividing by. And then these numbers actually came from the polynomial here. So I have a 1 in front, so here's a 1. The next number is an 8, so here's my 8. And then 6, and then -7. 6, -7. So it is the polynomial. I'm just not including x cubed and x squared and x. I'm ignoring those for just a moment to kind of simplify what it looks like. So now what I do is I go through and I'm going to bring down the first piece here. So the 1 gets just brought down. So I have 1. And then whatever's down underneath, I multiply by this number here. So -7 times 1 is -7. And then I add straight down. 8 minus 7, or 8 plus -7, is 1 again. 1 times -7 is -7. 6 plus -7 is -1 this time. -1 times -7 is +7. And -7 plus 7 is 0. This is actually kind of what we want to see here. That 0 on the end means there is nothing left over. It actually divided evenly into it. There was no remainder. So now what I do is I want to put my my variables back. And the one that I put here in red will actually kind of correspond over here with the same idea as we go piece by piece. It doesn't correspond exactly, only because we're doing the full division. These numbers would correspond when we get all the way down to the bottom here. So it's partially correct. I just didn't quite finish over here because we're using a different method of division. So now what we're going to use, the main thing to remember is we divided it down, and literally what that means is every x for the exponent is going to go down by 1 because we divided it down 1. So instead of it starting with x cubed, it's going to start with x squared. So we went down from a cube to a square, plus instead of 8, it's going to be 1x, because again, that's the next one. 2, this would be a 1. We don't need to put the 1 there though. And then 6 doesn't have an x anymore, and it's not 6. Now it's a plus, it's -1. So this is my new trinomial. So it's a new polynomial there, but when we divide it down, this is what we get, and we had a remainder of 0. So if this wasn't 0, we would just put that number in for what the remainder was. So this is just another method of dividing. And sometimes this can make it go a little bit faster when you have to do kind of a more intricate one instead of having to do this long division, because this tends to get a little messy looking as we do that kind of crazy long division when it's a very big polynomial.